Welcome to lesson 6.4, types of quadrilaterals. And in this lesson, we'll obviously be looking at different definitions related to quadrilaterals, as well as properties of certain quadrilaterals. So again, what you want to keep in mind is quadrilateral simply means a four-sided plane figure, or a four-sided two-dimensional figure. And then we're going to explore this idea of a hierarchy as well again, so we'll come back to this piece on the right. But let's start with a few definitions. We're going to look at four to begin with. First one, definition of a parallelogram. A quadrilateral is a parallelogram if and only if both pairs of opposite sides are parallel. So we don't care about the side lengths necessarily. For a parallelogram, we only care about that relationship if the opposite sides are parallel. The definition of a rhombus. Quadrilateral is a rhombus if and only if it has four congruent sides. So on this one, we're not concerned with the angle measure. We're looking at the four congruent sides. Then we have a rectangle. And the definition of a rectangle is a quadrilateral is a rectangle if and only if it has four right angles. So our definition of a rectangle, we're just looking to make sure it's a quadrilateral with four right angles. And then the definition of a square is kind of putting these first three definitions together. A quadrilateral is a square if and only if it has four congruent sides and four right angles. So now let's look at this idea of a hierarchy. So the hierarchy on top, you start with the most basic shape, or the one that can be split into more specific shapes. So in this case, our most basic shape is a parallelogram. Now the solid line going down means that a rectangle here is a special type of parallelogram. And rectangles always are special types of parallelograms. The dashed line here to rhombus means that rhombi, or rhombuses, can be a type of parallelogram, but don't always have to be. And then a rectangle and a rhombus both go down to a square because a square is a special type of rhombus and a special type of rectangle. So if we're looking at example 1 here, we're looking at all these different lettered quadrilaterals, and it's saying in the set below, you may assume that the segments and angles that appear congruent are congruent, and that lines appearing parallel are parallel. So they didn't do the markings or labels. So identify the parallelograms. We have quite a few. We have D, E, F, H, J, L, N, P. And in that case, our parallelograms were any of the shapes where opposite sides are parallel. Identify the rhombuses or rhombi. And in this case, we have four of them: F, H, L, and N. Then we have identification of rectangles. Again, four of them: J, L, N, and P. And then last but not least, identify the squares. Our squares would simply be L and N. Now we're adding a couple more definitions. Next up is a kite. And a quadrilateral is a kite if and only if it has two distinct pairs of consecutive sides of the same length. So consecutive sides means they have to share a vertex. So like side AB and BC are consecutive. Side AB and AD are also consecutive. They share A as a vertex. So in a kite, two distinct pairs of consecutive sides have to be the same length. So one pair would be AB and BC. The other pair would be AD and DC. So AB is equal to BC and AD is equal to DC. So a kite could look like this right here, which is a convex kite, or we could have a concave kite, where again, BA and BC are congruent, and then AD and DC are congruent. Then we move down to a trapezoid. And a trapezoid is defined as a quadrilateral is a trapezoid if and only if it has at least one pair of parallel sides. And the key there is at least one pair of parallel sides. So if it has two pairs of parallel sides, it ends up being a parallelogram, which is a special type of trapezoid. So parallel sides of the trapezoid are known as the bases. So in this example up here, DC is parallel to AB, so AB and DC are the bases. Then it says two consecutive angles whose vertices are endpoints of a single base constitute a pair of base angles. So for example above, A and B together, they make up this bottom base. They are base angles. D and C are a pair of base angles. B and C together are not base angles because they are not together on the same base. So now, example 2 tells us to use the trapezoids at the right. Name a pair of base angles of trapezoid EFGH. So in this case, GF is parallel to HE, so those are my bases. So base angles on bottom would be G and F. Base angles on top are H and E. Then in B, it says, name a pair of angles of trapezoid JKML that are not base angles. So in this case, all these sides, so JK is parallel to LM. But also, JL here with the double arrows is parallel to KM. So the fact that both pairs of opposite sides are congruent, that means all the pairs of angles are base angles other than K and L together and M and J together. So our base angles could be JK, JL, LM, and MK. Then we get into isosceles trapezoids. And a trapezoid is an isosceles trapezoid if and only if it has a pair of base angles equal in measure. So if angle A and angle B here are equal in measure, this is an isosceles trapezoid. Now, example 3 says, in the quadrilaterals below, same set as before, we're making the same assumptions that angles that appear to be congruent are congruent, lines that appear to be parallel are parallel. So all of our kites, we have quite a few, B, F, H, I, L, M, N, and Q. Our trapezoids would be C, D, E, F, G, H, J, L, N, O, and P. And our isosceles trapezoids would be G, J, L, N, O, and P. So now we get to the final idea of the quadrilateral hierarchy theorem. So based on the 7 types of quadrilaterals that we looked at, they are related, shown in the hierarchy below. Every property true of all figures of one type in the hierarchy is also true of all figures below that type. So, in other words, A rectangle is below a parallelogram, an isosceles trapezoid, a trapezoid, and a basic quadrilateral. So a rectangle has its own properties, but it also shares the properties of a parallelogram, isosceles trapezoid, trapezoid, and quadrilateral. So a square down here would share the properties of everything above it that it's connected to. Now, ignore the practice problems over here. Go with the ones that are posted with the assignment in Google Classroom, please.